This is going to be a short video over parallel versus perpendicular lines. Um, let's get some practice at finding the slope of a line given the equation. Remember your slope-intercept form, y equals mx plus b. If you can isolate the y variable in your equation, then your x term will contain the slope, your constant will be the y-intercept. When we're comparing and contrasting parallel and perpendicular lines, we're going to focus on the slope and the y-intercept, specifically the slope, but the y-intercept does have a role in it. First, let's go ahead and isolate y in this equation. Okay, I'm going to go ahead and subtract 2 x's from both sides. Basically, we're just going to move it over, change the sign of it. Divide everything by -5. And that's going to give us y equals, 2 negatives in the same fraction make it a positive 2/5. 1 negative in a fraction makes it negative. So just be careful there. Okay. Our slope is 2/5. When you're asked to find a slope that's parallel to a line, you use exactly that slope. Parallel lines have equal slopes. They have a different y-intercept, but their slopes are identical. For perpendicular, your line has to run in the opposite direction at the opposite rate. Now, numerically, it's easier said than done. You flip your ratio and change the sign. A positive 2/5, if reversed, becomes a negative 5/2. And what I mean by reversed is you reverse the ratio or reciprocate, flip the fraction, however you want to say it, and you change the sign of it. In this example, we're going to find the equation of a line perpendicular to the line given that passes through the point -1, 4. First, we're going to need to find the slope of the line given, and because we want to be perpendicular to it, once we identify that slope, we're going to flip the ratio and negate the sign. In the equation given, x plus 2y equals 2. Subtract an x from both sides. Divide everything by 2. One divided by 2 is 1/2. Don't forget the negative. And then 2 divided by 2 is 1. Okay, so let's identify our slope. Our slope is -1/2. Now, if we want to be perpendicular to that, perpendicular slope is going to be a positive 2/1, which is positive 2. We're going to use that slope and the point given, and because the point given is not on the y-axis, we're going to use point slope formula. Y minus 4 equals our perpendicular slope of positive 2. Let me do that in blue just so we keep it color coded. Times x minus -1. Okay, so that's going to give us y minus 4 equals Now inside the parentheses, x minus negative 1, that's x plus 1. So when we distribute the 2, we're going to get 2x plus 2. You got it. Adding 4 to both sides. Our slope's going to remain the same, 2x. And then when you add this 4, that's going to give you a y-intercept of 6. This line is perpendicular to the line given and also passes through the point negative 1, 4. Let's look on the next slide. Let's graph both of those and visually inspect to see whether or not they're approximately perpendicular via graphing. Okay, so the previous slide, once we isolated y in the given equation, we had y equals negative 1/2 x plus 1. Once we went through our process, we found the line that was perpendicular to that was y equals 2x plus 6. And then let's also remember our point given was negative 1, 4. Both lines are supposed to pass through this point, and they're also both supposed to intersect each other somewhere at a 90-degree angle. Let's see if that happens. Now I'm going to have to eyeball and hand draw this. If you had a grid, you could carefully draw by plotting points and using a straight edge, and you could really visually verify that these are going to be right angle intersection. Okay, negative 1/2 x plus 1. We're going to have a y-intercept at 1. The slope being negative 1/2 tells us we go down 1, right 2. That'll give us the slope of negative 1/2 with a y-intercept at positive 1. Now by hand sketching, you can get a pretty good look if you make your tick marks pretty well spaced, like consistently space them. 2x plus 6 has a y-intercept at positive 6, so we got 1, 2, 3, 4, 5, 6, and a slope of positive 2, which is also 2 over 1. So if we go up 2 more and over 1, I'm going to have to remove this y. Okay, so let me mark off 1, 2, 3, 4, 5, 6. This was our, I need to color code this one. All right, so we've got 0 and 6. If we go up 2 and over 1, that puts us up here at 1, 8. Now it's going to be very hard to make this come out to a right angle because I hand sketched it and the tick marks are not equally spaced. But had I done it correctly, let's see, I'm going to have to modify this a little bit. But anyway, the idea is when these two lines intersect, they form a 90-degree angle. I can give you a tip on your graphing calculators. If you use one of those, if you put the top equation in y1, the second equation in y2, and then hit zoom 5, which on your screen it'll be z squared. It will take your calculator screen, which is rectangular, and it will change your x and y axes, and where the calculator thinks it has a square screen instead of a rectangular screen, and you can visually see that these lines do cross at a right angle.